Thank you, Frank. First of all, I want to say that I am just really grateful to the selection committee for choosing me, and I'm very honored and humbled. But I also want to second the remarks of Dr. Wolchuk, who said that the science is not an individual sport, it's a team science. And I truly wish that everyone could have seen the dedication and passion with which all of my colleagues at Moderna worked for the past year, and they're still working to get the vaccine out to everyone in the globe. So I will accept this award, but on behalf of all of my colleagues at Moderna. It's been an amazing ride. I'm looking at Lavina. So I also want to thank the donors who make this foundation possible. And let's talk for a little bit about cancer. As a cancer survivor myself, I had breast cancer. I very much appreciate the need for more research. Now, breast cancer is one of the more common cancers that have seen many advances in early detection and treatment in recent years, and that's why I'm standing here before you today. But in considering where one can have the biggest impact today, I think the Hope Fund's focus on funding research into rarer cancers is a really smart move. Among these rare cancers, one that's touched my life a lot is ovarian cancer. I'm personally known too many women who've succumbed to ovarian cancer, many at the prime of their lives. In addition to my father's sister and another close personal friend of mine, two colleagues of particular note are Susan Lindquist in 2019 and Angelika Amund in 2020, both of whom were highly respected MIT professors making seminal contributions in their respective fields. I can't help but wonder if there was a method for early detection, if these amazing women would still be with us. As for my own research, I never worked directly on cancer. Rather, my work dealt with elucidating the basic mechanisms of gene expression and how things work normally. At its most basic level, of course, cancer is a problem of gene expression gone awry. When I was a postdoc in Philip Sharp's lab at MIT Center for Cancer Research, my mother would regularly ask me what cancer I was working on. Now, she was very pragmatic, and she was very much a believer that all research should be directed at solving a particular problem. So she didn't really have much use for curiosity-based research. So I over many years, I have a funnier story about that. When I got to UMass Medical School, she was walking with me in the halls, and she said, "Now, Melissa, is somebody finally going to tell you what to work on?" But I would try to explain to her that in order to fix a problem when things go wrong, like cancer, we first need to know how the human machine works normally, all the way down to the molecular level. It's only through gaining this deep understanding of molecular and cell biology, as well as immunology, that some of the amazing new treatments for cancer, like we just heard, the checkpoint inhibitors and CAR T cells, have become possible. Now, at Moderna, we're applying other learnings to develop not only vaccines, and we have many, many more vaccines in the pipeline, but we're also working on cancer therapies. So we're working on personalized cancer vaccines, other therapies that will heat up the tumors to get the immune system to recognize them. We're working on therapies for rare diseases. We're working on therapies for autoimmune diseases. But we couldn't have done this without the basic research that had gone into mRNA. And I do want to note that 2021 is the 60th anniversary of the discovery of messenger RNA. And so it's been quite a long time. Now, if we go back 30 years ago to when I was a postdoc and I was investigating the mechanisms by which messenger RNAs are made and then used to blueprint proteins, and I can tell you that one of my heroes at the time was Joan Steitz, who's sitting right there. If you'd asked me if someday if mRNAs could be medicines, I would have told you you were crazy. So I want to applaud the wisdom of the Hope Fund's postdoctoral fellowship selection committee in funding young scientists who are still working to uncover the fundamental truths about how normal biological mechanisms work. Although these types of investments might not pay off in the short term, in the long term, some will undoubtedly pay off big, like the COVID vaccine, by revealing previously unimagined avenues to combat disease. And let's hope one of those avenues leads to early detection or a cure for ovarian cancer, which has taken far too many of the women in my life too soon. So thank you again for the recognition.